Alright guys, today we're going to continue talking about the different forms of linear equations. We're going to pick up with the next one, standard form. So just sort of recap what we've talked about already. We've already looked at these other two forms of linear equations, slope-intercept form and point-slope form. So with all of these forms, you need to really remember that they all have a purpose, or they show you something relatively easily. So with slope-intercept form, well, the purpose and what it shows you is in the name. It shows you the slope, and it shows you the y-intercept. So you can see right in the equation, for example, if I had y equals 3x minus 4, that would mean my slope is 3, and my y-intercept is negative 4. So that's the whole purpose of slope-intercept form, is it's easy to see your slope and it's easy to see your y-intercept. Usually going to be the most useful form for you. Point-slope form, again, it's in the name. It shows you a point on the line, and it shows you the slope of the line. So if, for example, I had an equation with a slope of 3, and the point, let's do 6 comma negative 2, this would be written in the point slope form as y minus negative 2, but since it's minus a negative, it's going to look like plus 2 equals, and then we plug in our slope, 3 parentheses x minus 6. So in this equation, I can see my point. You do have to do a bit of thinking, but my point is 6 comma negative 2, and my slope is 3. So point slope shows you a point and the slope. Standard form, probably the least user-friendly, but it does have a purpose. So standard form its purpose is to show you both intercepts. So we've talked a lot about the y-intercept, but there's also an x-intercept. And we'll look more at the x-intercept later, but in theory, that's what standard form can show you. So we're going to write used for finding both intercepts. Meaning the x-int and the y-int. Here is the standard form. A x plus b y equals c. So just like with any of our other linear equations, there is a place for us to plug in the x and the y values that fall on the line. It's just this time, instead of x being the only number that has a coefficient, our y is going to have a coefficient as well. It being set up this way makes finding the slope a lot more difficult in this form. And usually the best way to find the slope is going to be rewriting this equation. So we're going to have to do a lot of equation manipulation for this form to become useful. In this form, here are some things that need to be written down. A, B, and C are integers. So that means they're going to be whole numbers, basically. So this A can be a number like 2, this B can be a number like 3, and C can be a number like 6. And we'll actually look at that example in a second. Another rule is A and B cannot both be equal to 0. So if I had a equal to 0, 0x, I can't have 0y as well. It just wouldn't work as an equation. And sometimes I do show a little trick that you can maybe use to calculate your slope and y-intercept. I don't recommend it being your only method for finding the slope and y-intercept, but it does technically work. If you take a divided by b and flip the sign, or negative a divided by b is another way of thinking about it, this is going to tell you your slope every time. Another trick to help you find the y-intercept, again, I highly recommend that you learn how to rewrite this equation in slope-intercept form. But if you take c divided by b, that'll tell you your y-intercept. So you can get the information that's useful for the line out of this equation. It just takes a little bit of work. Another couple things about this form. A should be positive. And then again, x, that is your input or independent variable, and y is still your output or dependent variable. So now what we're going to do is, we mentioned that this form is useful for finding both intercepts, the x and the y-intercept. So we're going to do a little section here where we calculate these two intercepts. Calculating the intercepts for 2x plus 3y equals 6. So before we go and talk about how to rewrite this and find our slope and find our y-intercept, we're going to at least take a look, at least once, at how we can use this form to calculate the intercepts relatively easily. So one thing to keep in mind, let's just start with the one we're more familiar with, the y-intercept. For the y-intercept, something is always true. So you might be thinking on a graph. Well, the y-intercept is where the graph crosses the y-axis. And if we take a look at this same equation, I've written it in this illegal Desmos, as we call it sometimes in my class. It's going to graph it for you. But if you go into the STAR Test Desmos, it will not graph these standard form equations for you. You need to convert them into slope-intercept form. But I have this equation graphed for us. Let's take a look at our y-intercept. It's 2. But what's true about all y-intercepts? My y-intercept for this equation, y equals 5x plus 4, what is the same between both of these y-intercepts? Hopefully you notice both of these y-intercepts have an x value of 0. Knowing that fact, we can actually take that information and use it in this form to relatively easily calculate our y-intercept. X is always 0. This is relatively important information to understand about your y-intercept. So what we're going to do is, if we write this equation, 2x plus 3y equals 6, knowing that x is always equal to 0, I can plug in 0 for x and solve for my y-intercept. So let's go ahead and try that out. If I plug in 0 for x, I just need to figure out what y is when x is 0, because that is the definition of my y-intercept. Plugging in 0 for x gives me 2 times 0, which 0 plus 3y equals 6. I didn't need to necessarily write this 0 here, but just to really show you that this essentially removes the variable from the equation. Now I have 3y equals 6. So what's the next step to getting the value of y, or isolating y completely to see what y equals in this equation when x equals 0? I just need to divide both sides by 3. So I'm going to go ahead and another color just to show another step being done. 3 divided by 3 cancels out. I get y equals 2, which exactly matches the y-intercept that we saw when we calculated or when we looked at the graph, I guess. So my y-intercept is 0, 2. Here is the y-int. All right. So now what we're going to do is the same idea, but this time we're going to be looking at our x-intercept. So we did it on the left. With the y-intercept, something was always true. X is always equal to 0. Well, let's take a look now at an x-intercept. We haven't looked at the x-intercept too much so far, but maybe you can imagine what the x-intercept means in a given equation. So if I look at this line here, there is a place where it crosses the y-axis. That's the y-intercept. Well, there's also a place where it crosses the x-axis. That's the x-intercept. Pretty straightforward. If you understand the y-intercept, the x-intercept is not much of a stretch. But here, if we look at our two x-intercepts, maybe you can notice this time something that's true for both of them. Just like how the y-intercepts both had x values of 0, the x-intercepts both have y values of 0. In the same way that we were able to plug in 0 for x to find our y-intercept, we can plug in 0 for y to find our x-intercept. So let's use the same idea. The x-intercept is where y is always 0. Okay, good enough. Let's go ahead and again with the same equation. Maybe you noticed what the answer should be when we were looking at Desmos. But if you didn't, now's the time to test your ability to calculate the y or the x-intercept. So remember, we're going to plug in the thing that's always true for my x-intercept, which is that y is equal to 0, and then solve to see what x is when y is equal to 0. Maybe pause the video here and see if you can calculate the x-intercept this time. So, again, this cancels essentially. I'm going to keep it just to really show each step. But 2x plus 0 is just 2x. It doesn't change. 2x equals 6. And now, my last step, just like it was over here, is to divide by my coefficient in front of x. Divide by 2 on both sides, and I get x equals 3. And again, this time, instead of my y-intercept, it's my x-intercept. So my ordered pair is going to be 3, 0, which, if you were paying close attention to Desmos, was the exact same x-intercept that it gave me on the graph. Okay, so that's at least the basics of what standard form is, what it's meant to be useful for. What we're going to look at next is how to take standard form and rewrite it in slope-intercept form so we can see its slope and we can see its y-intercept in another way.